So drainage, right. So as there are many different kinds of membranes out there, there's also different ways to drain your Ecoroof. One of the ways, the first one, of course, is just sloping your roof at 2% or more to get that water moving. There's a porous soil that we might be putting up on our roof that would facilitate that horizontal movement of drainage. There's maybe a way that we would put a gravel sublayer, so there'd be a gravel lens and then put maybe a little bit smaller aggregate or tighter, more Ecoroof soil above that, and that would allow that horizontal drainage. We have drainage channels and also then maybe a drain mat that might work. So roof slope, of course, I already took a peek at this one. The steeper the slope, the faster the water is going to drain. Definitely considering, I think there was a question there about that specific issue, is that if you're going to have a steeper roof slope, is there going to be less water there for the plant material? And it's likely that there might be, because that water is going to have less time, it's going to be moving faster through that soil and maybe a little bit drier. So greater than 20%, we're going to do soil stabilization measures because that water is moving horizontally through that soil system, so you want to be sure to have some baffles to keep that soil intact as it drains off of a steeper roof. So one of the ways is just porous soil. When that water is saturated, if you just had a porous soil system and a 2% pitched roof, that water is going to saturate, and then that water, if it's a heavy downpour, is just going to move horizontally across the top of that of your soil. And I think we're talking about smaller to medium-sized drainage areas. If you have, let's say, a rooftop that is broken up in, I don't know, maybe 5,000 square foot or 2,500 square foot sections, then that distance from the farthest point of your little roof shed to that drain, maybe not such a great distance that the water's really going to pick up speed and cause some erosion. And so maybe all you need is just a porous soil that's going to allow that water to move laterally through there. And so on smaller, medium-sized projects, that might just be a good way to go. Soil in general, obviously the higher porosity soils that you have at the top are higher mineral and lower organic content, which seems to be kind of where soils are going when it comes to eco-roofs. But you have the middle, which might be kind of a 50-50, and then the lower, we're getting into lower mineral and really higher organic content soils. They may not drain quite as quickly, like we were talking about maybe with the EcoTrust example, but maybe be better for water retention. And so what we're still trying to figure out is that the soil porosity seems to be this higher mineral, lower organic content, but what we're also looking at is maybe in a few years we're going to be looking at what are soils that do better for stormwater retention or biodiversity or you name it. So there's going to be, I think, once we kind of settle on a core Ecoroof soil that we're going to be using, and then we start focusing on all of these other benefits, that maybe there's going to be a lot of different soil mixes that will come out of that. But right now there's quite a range that have been installed over the years from high mineral content to lower, but it seems like more of them that are being installed are that high mineral content. So gravel or rock sublayer, maybe perhaps the oldest system that's out there for draining eco-roofs. System was used in water reservoirs in the early 1900s in both the U.S. and Europe as a simple drainage layer. But due to weight requirements or weight restrictions and the advent of plastics, it seems like if there's a product out there that can do the same thing, we might as well just use that. Well, we don't know. There's definitely some systems that are out there where they'll do maybe 1.5 inches of growing media, and then they'll do maybe 2 inches of an expanded clay or a higher aggregate that will drain that water faster, but also create that water retention layer. So that's where there's a lot of that dichotomy between getting rid of that water, being able to shed it, but then also having that layer hold on to that water as well. So I think gravel layers obviously move that water through, but maybe there's other aggregates out there that can be used that also hold water.
With a gravel layer, do you use a filter fabric to keep it from silting up?
I don't know. I haven't spec'd a gravel layer system, but Yeah.
I think there's both ways to do it.
Yeah, I was going to say, if you have a, you can see many times, because even the layer above it is still an aggregate, that you may not need to. So.
Are you also seeing soil textures identified for soil types for the eco-roofs, like silty loam, sandy loam, clay loam? Are you seeing an analysis of the soil texture based on the sand, silt, and clay particles for those systems?
So far, percentages of material is what it's been. That's what I've seen.
Yeah, in our area,
It's just one component of the soil. I'm thinking more of the physical properties of the soil particles.
Right.
Yeah.
If you go in, it's interesting. If you look at like the FLL guidelines, they talk specifically about size of aggregate and then also percent of organics, and it says like 7% organics, and that organic is then broken out into clay and silt and those particular percentages. So there's definitely that detail in at least the FLL guidelines, but as for what we're seeing as specifications coming through, I don't think things have been broken down that much yet.
I think that'd be the way to hold the spec of what type of soil texture you're looking for because of drainage or because of water holding capacity.
I think so far in our area there's work going on up in Seattle with regard to trying to develop a spec that works for stormwater management, not necessarily the best plant survival, because there's some engineers working on stormwater management. And so far in our region we have 3 companies that we know of that are providing soil, and one company which is on our list of companies, they just basically say, here's my Ecoroof blend. And that's what you get, and you can ask them for the particulars of that. There's another company up in Longview that's associated with a German company, and they use the German blend, which supposedly would be perhaps meeting the FLL guideline. And then there's another company in town that's, or near in our region, that is also starting to provide soil. And perhaps there are others, but 3 that we know of that are soil providers that are into this business. And
So another way of just moving water through your Ecoroof may be drainage channels. So the example photo here is at the Metro building, where there were like lava rock channels installed as part of the design of the Ecoroof. So it was a very aesthetically interesting design that also used these gravel channels to move water through that. So that was the zone of kind of low pressure. The water would move towards those because that's the most open poured channel, and then that water would move then towards the drain. So it's an interesting way of doing it, and either, if you had something like this that either went along the contour or the valley of your roof, let's say if you have it shading down in a V, you could put that channel down the bottom of it, or horizontally across a steeper sloped roof. So it would pick up the shorter sections of water, move it down maybe to a drainage system rather than having it flow all the way down and potentially cause erosion. So that's another way of using these drainage channels. I think they're very effective. And then, of course, we have drain mats. We have some examples up here, lots of different kinds, some that hold water, some that don't, some that have filter fabric adhered to both sides, some that are, can be actually adhered to the roof deck. You name it, all different thicknesses, inches, an inch thick, half inch, whatever it might be. And they're all, it's funny, they can be turned upside down in many different ways. You see one installed and say, no, we got to flip that back over because we want the cups up to hold the water. And so whether they were designed specifically that way or not. So anyway, lots of different ways about going about drainage channels. And just to give you an example, here's on the Portland building where we have a drain mat. Then there's the filter fabric, that gray filter fabric above it, and it was installed on top of the insulation layer. You can see right there. So there's our root barrier, the blue. I'm sorry, you didn't see where I was pointing. Right there. So root barrier right here, then insulation, and then there's that drainage mat. So again, here's drain mat, and then insulation layer, and then filter fabric, and then soil was installed on top of that.
Is that additional insulation in addition to the insulation that's required for a dwelling, or is that part of the insulation needed for the dwelling.
This is required by the city code for any, if we were just re-roofing this building, they said we needed our R19. So even if we didn't do
retrofitting on the inside, you're putting on the outside.
the insulation on the building was
on the side. It was designed that way. Yeah.
Actually, what's interesting about this building is that the insulation for this building on the original membrane was laid on top of the deck, and then it had the waterproof membrane, which was an EPDM, over the top of the insulation, and it was 1.5 inches, because whatever the code was back then. And then on top of the EPDM membrane was all the gravel, which gave us the structural capacity to hold the Ecoroof. And so that is kind of a standard for EPDM that was used quite a bit, because the gravel holds down the insulation and the whole system, and you don't have to have fasteners and all kinds of other things. And it actually seems to me like it's a system that was a pretty good system, and a lot of people have gone away from that approach. But anyway, so that's what we had. And then in the redesign, with the consultants involved and everything else, they thought this opposite approach was better. So the membrane, and it's not an EPDM, it's an asphalt material, so it goes on the bottom, and thus we have this.
One thing about the insulation that I've learned, there's waterproof insulation. This one gentleman asked about leaving the old membrane, putting insulation, and then putting another membrane on top. I know that blue stuff, I think, doesn't absorb water, where the insulation that goes underneath a typical membrane does absorb water. And I think that's a little bit more expensive, so that you'd have to kind of value engineer it to see if that. But I just wanted to.
That's good. Thanks, Mike.
Yeah.
Yeah. So.
Does that mean that your insulation can go less because the Ecoroof itself can?
Not yet. Perhaps never. But so far, there isn't any R value.
But if you throw a little bit of the pellets in there that has some insulation quality.
Currently, the work that's going on in our region is Portland State University has set up wind tunnels or chambers. It looks like a pizza oven. And they are testing different Ecoroof sections and plants for stormwater management, and they're trying to come up with an R value. And so far, I talked to the professor the other day, and he said, okay, there's nothing that's conclusive. So he said they're getting R value readings of from 2 to 8 for soils from 4 to 6 inches. And he said there's and that there isn't necessarily a correlation between thicker and more R. They're getting sometimes, it's like stormwater, it's like random. It seems the answers just don't comport with what we think we know about energy and things like that. So it doesn't appear, even at the best reading of 8 for, I assume that's the 6-inch soil, that it's going to be a dramatic R value. Now, and they've only measured for warm temperatures. They haven't measured for cold temperatures yet, so we don't know what that's going to be. So this is just warm temperature monitoring. And then the other thing that's interesting is that they're not studying the reflective characteristics, and I don't think the word's reflective. In other words, reflective roofing doesn't really have an R value, but it reflects that heat, so it prevents, so in a sense it's like got a certain R value in a sense, but it has a different value. So the vegetation and soil absorbing and or reflecting the heat and such is to my knowledge, has not been studied, at least not in this country. I'll bet the Germans are looking at it, but not in English yet. Or maybe it is, and we haven't seen it.
This system here, clearly the water is going through the insulation. I mean, some water is going through the insulation.
Going through those little holes and getting around the insulation, yeah.
And is it going through, is it typically designed to go through the seams of the insulation or through the insulation?
I would say
that would be a waterproof insulation.
See a little notch cut out right there between the seams of that insulation.
Okay.
So that might be a little bit.
It has grooves
drainage
underneath
channel
it.
to promote that water.
They're cut in the bottom of the insulation to facilitate the movement of water.